If you fail to round properly, you tend to lose some accuracy in any kind of prediction and outcomes. We talked about this a little bit when we talked about regression and correlation, and I think I got the point across because if you're off by even the slightest margin, in some situations it might not be a big deal. Like, for example, if I'm grading tests and I'm off on your score, let's say you got an 89.01 and I accidentally put an 89.02. I don't round like that, by the way. But if that were the case, then that's not really a big deal. You're not going to lose too much sleep over that because it's not going to impact your score in any kind of meaningful way. But if that rounding error is in the trajectory of a projectile or a flight plan or something like that, these are things that could be catastrophic in nature. Uh, Depending on the units that you're using, it could be lethal if you're talking about dosages and medication. So rounding could be a pretty big deal. So some cases it matters, some cases it doesn't. So in this case, what we're going to do is we'll use a rounding rule of 3 significant digits. All right, this is not the chemistry sig figs if you're familiar with that. This is simpler. All right, 3 significant digits means the first 3 values after the zeros end in the decimal. All right, so ignore any initial consecutive zeros. Then start your rounding after the zeros end. So in the first case, after the decimal point, there weren't any zeros to start off, so I just go to the first 3 values. And that'll be in most cases. In almost all cases, it's going to be just the first 3 decimal values. But in the case of the second example, we have a bunch of zeros that lead things off. So I'm going to ignore those. I'm going to start counting once the zeros end and get 3 values after that. That'll be my rounding instructions, or my rounding convention procedure. And it works very, very well because if you have numbers that are kind of in the realm of the second decimal value there, 0.0000721, and you have another one that's 0.0000821, if you rounded both of those to 3 decimals, you get 0.000 in both cases. It's like, well, there's no meaningful difference between the two of them. But if you go out to 3 significant digits, then you do get a meaningful difference between the two of them. Right? So basically, it would be the 3 digits that you would be using if you were to write this in scientific notation. Right? If that's something that's more familiar to you. Your calculators have scientific notation modes. It's not overly user friendly. So, I mean, I can pull it up. So in your mode menu, you have normal, SCI, and ENG, scientific notation. Puts everything in scientific notation. One times 10 to the 0th power is what that translates to. Okay, so if you have it in its more notable format, it's a little easier to see how that's equal to 1 because 10 to the 0th is equal to 1 and 1 times 1 is 1. Now if I take this ghastly looking decimal here, 72098, hit enter, and it converts it over like this. Okay, so, and again, this is not by any means required. If you look at, this is one of the few techniques in this course where I'll say, if you don't like this, then don't even bother, because it's, for a lot of folks, it's more trouble than it's worth. Especially if you're still at the point where you're just memorizing calculator steps and not really understanding why you're doing it the way you are in the calculator, if you're still there, then this may not be for you yet. All right, so I type in the decimal, it converts it over into scientific notation. At this point, we would take the first three values, and it would become 721. Now, at this point, you can represent your final answer one of two ways. You can go back to the original decimal form from the scientific notation, or I will accept a scientific notation answer. That's perfectly fine. So 7, you'd write 7.21. You could even write the E -5 if you want. But that means the same thing as 7.21 times 10 to the -5th power. All right. Some people have said that they like the scientific notation because they know they could just round whatever comes up on their screen to the first three things, the first three numbers that they see. They don't have to worry about ignoring zeros. Other folks say, well, listen, I plan on working in fraction form the whole time anyway, so forget the scientific notation business. Then there's other folks that say, I would use it, but in another class, it's going to be confusing for me, so I want to keep it in the normal mode. A lot of different reasons why you would not want to do it this way. Maybe not. I don't know. You decide. Odds in a course. Your odds of passing the course are pretty good. Now, if you're still here, if you're still showing up, yeah, the odds are pretty good. Got to turn in your work, but aside from that, things generally work out. And in fact, usually the folks who don't get the grade that they wanted to get in the course, it usually had nothing to do with tests or anything. It usually had to do with not turning in the other assignments, like tech assignments and things like that. So yeah, your odds dramatically improve if you do those things. Now, in terms of gambling or things like that, you see odds all the time. It's usually payoff odds. And in some cases, the payoff odds are the same as what the actual odds are. Like horse racing, that's the example I use below. But sometimes they're different. If you have payoff odds in the case of the game of roulette, which I've alluded to already, but we haven't gotten into the intricacies. We'll talk about specifically the game of roulette, I think, next class. If not next class, the following class. I like to dedicate at least some time talking about games of chance. Right? But yeah, the payoff odds for if you bet on a single number, they pay out at 35 to 1. So 35 times your wager. But the probability of you winning on a particular event is you have a 1 in 38 chance. So they don't line up evenly, which is to the house's favor, because if they made it an even payout, let's say you bet on 38 consecutive spins, lost the first 37 but won on the 38th, then that 38th win, the win on the 38th, would pay off all of your debt from the first 37 losses. The house doesn't want that to happen. They want you to always be playing at a disadvantage. Right? So what they do is they pay out at 35 to 1. Mathematically, there's a reason behind it. It's called expected value calculation. But at this point, it really is just the house wants to make money. Right? So you win on a 37th spin. So let's say if it was $1 a spin, you would, if you lost on 38 consecutive spins, you'd be out $38. But if you lost on the first 37, you're out 37. But then you win on the 38th, you get your wager back and $35 new dollars. Right? So that doesn't cover the $37 you lost on the first stretch of spins. Right? So you're still $1 short. Right? So you want to be in a situation where you're ahead of the game, but that doesn't really happen in the construct of these games of chance. What you want to do is you want to come up with a strategy that allows you to excel within the framework of what's available to you. So it's kind of like you go into a class and you have a teacher that like, you got to take this class, and Professor so-and-so is like a tough SOB. Like, and we've had this before. It's like, oh, I didn't want to take this teacher, but this is the only time I can take the class. It might be right now. Hopefully not. But if that's the case, you're already playing at a disadvantage, right? So you want to somehow, some way get an A, but you have to do something extra in order to make that happen. It's really the same idea. All right. So now, in terms of actually figuring out the odds, when you talk about the odds, you generally talk about the odds against, all right, because that's what generally determines your payout. But odds for would be probability of success over the probability of failure. All right. This is success, and this is failure. All right, so I'll do something along the lines of roulette, even though we haven't talked about the game very much. In fact, today's the first time. Let's say odds to win on the number 8 in roulette. All right, so a lot of given information needs to happen here, right? Because I can't expect that you would know it. So you have a 1 in 38 chance of winning. So we would need the odds to win would be the probability of winning against the probability of losing. You have a 1 in 38 chance of winning. You have a 1 in Jeez Louise. Saturday morning. 37 out of 38 ways to lose. If that doesn't dissuade you from gambling, I don't know what does. Like, just seeing the numbers, like, there's only one way that I could, like, there's always one way that you can win. But it would be nice if it was out of 2 possibilities or 6 possibilities. Here it's out of 38. It's not a wise investment of your money. All right, this simplifies down to 1 over 37. But we would also say 1 colon 37, or even write it out as 1 to 37. All right, they all mean the same thing. 1 win to 37 losses. 1 way to win, 37 ways to lose. All right. Odds to lose on 8 in roulette. It's the same idea, it's just a reciprocal. I'll write out the steps, but all I'm doing is writing the bottom on the top and the top on the bottom. All right, so there's 2 different ways to represent odds. Odds in favor of something happening or odds against something happening. When you win in a game of chance, you're winning against the odds. Right? The odds are not in your favor. That's why you're gambling. That's the definition of gambling. If I were to say, all right, you could try to drive, it's snowing outside, you could try to drive to work today, but it's going to be a gamble. Now, you're not going to be thinking to yourself, okay, so my chances of getting there are good. I'll be fine. I ain't thinking I'm as good as dead. It's a gamble. Like, you're taking your life in your own hands. That kind of situation, So that's against the odds. So when you're dealing with a game of chance, horse racing, whatever, it's the 37 to 1 that you see. You don't see the 1 to 37. All right? And generally in those kind of situations, so it's definitely worth knowing the rules of the game. In those kinds of situations, the odds for, the odds against indicate what the payout's going to be. All right, so if I know that I'm 37 to 1 against the odds, if it were a horse race, then that would mean I would be winning 37 times my wager, which would be great, except it's not the case in roulette. I only get 35 times my wager, which is not as nice. Right? So a simpler example, non-contextual, but definitely has its place. A fair die is rolled. Determine the odds to roll a 4. So that's 4, a 4. So that would be probability of getting a 4 over probability of getting not a 4. All right, so 1 out of 6 to get a 4. On a die, I think I have a die somewhere in my notes. I meant to put a diagram in, a die. Oh, there it is. Oh, it got cut off a little bit. Whatever. I mean, as terrible things happen, that's not the worst. But I'll just tuck it in here so you see. Oh, undo. This is an unwrapped die. When you fold it all together, it ends up being a 6-sided number cube. But this is what we're talking about here. I remember when I first started teaching this course, I'd come in and be like, all right, so we're going to roll a die, everybody's nodding. We're going to draw a card from a deck, everybody's nodding, everybody knew. And it was like they're teaching me how to gamble. They're like, did you know about this, that, and the other thing? And then as the years went by, I realized that less and less people knew about this stuff, to the point where on a test, it's not going to say a die or dice. It's going to say 6-sided number cubes. All right, so it just to play it safe. Because I actually had to spend half of this 3-hour class session. It's supposed to be 4, but 3-hour class session. I spent like a good half of it trying to explain how a deck of cards worked and like why they worked and what was the structure of it, and it was almost to the point where it wasn't even really worth it. So we have, I get a stray mark there. We have 1 4 out of 6 possibilities. The other values are not 4s. Here's a whole lot of not 4s. In fact, a total of 5 of them. Then we simplify. When you have a fraction over a fraction, if the denominators are the same, they go away. That's how I'm doing that magical little step. I'm not using the calculator, just saying, look, denominators are the same, so kill them. That sounded harsh. But that's what it is. All right, so 1 over 5. I really don't like writing it as a fraction. I prefer colon or just writing it out verbally. Just because when you write it as a fraction, you think of it as a fraction, you think it's kind of the same thing as probability, but it's really not. Right? It's a ratio. It has probability components, but it's not a probability itself. All right. Payoff odds, at long last. The example, suppose the payoff odds for a horse to win the Kentucky Derby is 14 to 1. What would be the payout for a $500 wager? Right, so the rules vary depending on the game. Some games of chance, you get your wager back, like casino games. You not only get what you won, what your winnings are, but you get what you bet originally. For horse racing, you don't get the bet back, right, because you paid for the ticket. So they don't hand you the value on the ticket and then an additional like $10 for your wager or something like that, right? So your wager is forfeited, but you don't care because you just won 14 times $500. So you don't really care about the 1 times $500 that you're not getting back, right? So net depends on the game. Sometimes you get the wager back, sometimes you don't. And lottery tickets work the same way. Not all of them, but some of them. Right? Scratch offs. You buy a scratch-off ticket, you win. They don't then give you an extra $1 for a new scratch-off ticket. But I haven't played the regular lotteries in a while, but I remember there used to be one called Take Five. I don't know if it still exists, but that one of the prizes, if you won anything. So even if you won the jackpot, it was kind of like an extra little thing, but you always got a free ticket. So you win, you get a free ticket also. All right. Now, if you won the jackpot, you don't care about the free ticket. In fact, most people are like, "Well, I'm never gambling again. This is it. I'm set." But if you won like one of the little prizes, like $10, you're like, "Oh, okay, I'll take the free ticket too," because then you could say you won $11. So there are little things like that come into play, but that has to be explicitly stated in a problem because I can't guarantee that anybody would know about that. Like when I said Take Five, 10 years ago, everybody was nodding. Now, like, yeah, maybe still exists. So we want payout for a $500 wager. All right. So payoff odds. We'd have the profit here, which would be 14 times your wager. But then in this case, the horse racing case, you don't get the wager back. So not this time. Little exclamation point. And then we divide by the wager itself. All right. There's little shortcuts to this that kind of save you from writing any of this, because if you think about it, I kind of mentioned it before, you're going to get 14 $500, 14 of those $500 as your winnings, but you're forfeiting one of those $500. So you're really getting 13 new groups of $500. So you could just figure it out that way. But you could also, if you're a procedural person, you just follow the technique of multiply by the wager, subtract the wager, divide by the wager. So 14 times 500 minus 500 divide by 500. I left it in scientific notation accidentally, but the calculator can still do fractions even in scientific notation. So math, enter. The calculator can't do fractions if it's in scientific notation. So 13 is what we would get, but the odd should be in the form of a fraction. So we'd write it as 13 over 1, or where did I get the 14? Yeah, from this. Right, so the payoff odds.
So the net.
Oh, sorry, this.
The wager.
The net.
That's the definition of a net.
No, it's what you walk away with after you make the wager, after you win the whole thing. But I just realized I misread the problem. Considering I wrote it, that's kind of tough to do. It's very weird. The question was asking for a payout, not. We already had the. Fool. It said it right there. Like, how did I miss that? The payout is just the top. Right, because they gave us the payout odds in the problem. So it's 6,500. I think I know what happened. I changed the problem from the last 17 years I did it. So just the numerator. Multiply the payout odds by your wager, and then subtract the wager. Now, a new example, I'm in a new example kind of mood apparently, that I'll chuck in for the for next semester, so somebody could submit it as a typo. Similar structure to the previous one, so same Kentucky Derby thing, but let's say the payout odds were 7-2. What would be the payout for a 500 wager? And by the way, just so you don't think I'm a degenerate gambler, if you have a problem, you should call 1-800-GAMBLER. By the way, but like all the gambling sites, commercials, and everything, they always end with that. So I figure if I'm going to teach a lesson about gambling, I should probably say it too. I should probably put it. You know what? Somebody take that as a typo. Put like a little, yeah, another asterisk at the bottom saying gambling problems. Call 1-800-GAMBLER. I'm kind of joking and being silly, but I'm kind of not. Like, if you do have a problem, you should probably, you know what? You should probably just stop paying attention to what I'm sharing with you and just like suck it up and get this problem wrong on the test. Just like I don't want to know, because my goal here is not to make the situation worse. It's just to inform. Right? But anyway, the whole 7-2 business, because all of our previous ones had something to 1. So it was a matter of just taking the first number and multiplying it by whatever the wager was. Here it would not make sense in my payout to take a 7 and multiply it by 500 and subtract the 500. That would be a problem because it's 7-2. All right? So how do we handle that? Well, we make it so that it's something to 1. So I'm going to divide each part by 2. So I get 7/2 to 1. They mean the same thing. And in doing that, I now have my first number as anything, and the first number could be anything. The second number is now a 1, and that's what we need. All right, so this is a little bit, it has been a little tricky in the past, and I don't want it to be. So, and you see it all the time. I mean, I don't know how much experience you have with this, like sports gambling and things like that, but you'll see a team has 4-3 as their odds to win or odds against or whatever it is, and it's like, how does that work? It's just because they didn't want to write it as a fraction. They didn't want to say that it had a 1 1/3 to 1 odds to win or odds against winning, right? So it makes it a little bit cleaner in terms of the numerical values. 1250, I think it's so. But you want to go into a situation knowing what you're going to walk out with. Why gamble if you don't know what your payout's going to be? I've been at a roulette table before where a person who just blew like $15,000 won on, you know, like you could bet red and black. I don't, if you have no experience, this is all going over your head for now, but it'll be more obvious later. But you can bet on the colors too. And the colors are roughly a 50-50 chance of coming in. There's red, there's black, and there's a couple of green ones just kind of mess with everything. And a person literally lost $15,000 and then put $100 on red, won that one round, and then started like rejoicing like they just won a presidential election. Like, yeah, no, I'm like, okay, shit. So now you're only down $14,900 or $800 or whatever it was. I'm like, are you stupid? What's wrong with you? And this is the reaction. This is the I don't know what this era is called, but the 20 teens, I guess. I don't know. The reaction is almost always, whenever you say something like that to someone, they're always like, what? It's almost always like that. You ask somebody, I walked into the gym, I was like, hey, you guys using this basketball court? Because I want to shoot around with my son. What? Everything's what? That's all there. It like reverberates in my mind, and I'm like, can you not do that? It's like it's crushing my soul every time you say it. Like just do something different. And so that was a situation there where I honestly don't think that this individual was trying to do that on purpose. I think he really was caught off guard. Like kind of like why are you trying to take this away from me? Like, I'm not trying to take anything away from you. I'm just trying to figure out how you're going to pay your mortgage for the next 3 months, 4 months, year, whatever. Like, you blew a lot of money, dude. That's not good. Not good.